Welcome back on another session of technical mathematics, and we are still moving. In our previous encounter or session that we had, we were dealing with finance growth and decay, and I believe that all important aspect of finance growth and decay I was able to cover and give clarity where clarity it is given. And now we are moving on another section of technical mathematics, that is called graphs and function. And the paper that we have in front of ourselves is from November 2024 from Free State Province. Particularly those learners who were doing grade 11, there's a paper from grade 11 that was written by the learners who are residing in Free State, and those learners were 2024 academic learners. Now here we are going to deal with our function. Question number 6.1. It says, given the function defined by f of x is equal to, in bracket, 1 over 3 all to power of x minus 1. Candidate learners, it is of importance before you do anything to the given function, you must first know what type of function are you dealing with. In this case, examiner was lenient to us that he gave us only one function to deal with. In this case, the function that we have here, it is f of x. Now, what type of function is? Remember, for you to know what type of function it is, you must check variable x, where x it is, whether x is a base, whether x is an exponent. You need to check what is happening with an x. Then in this case, we see that x is there at the top. In this case, x is an exponent. We see that x is at the top, meaning that our x, variable x that is given in this case, it is our exponent. Then, since x is an exponent in this regard, it means the type of equation or the type of function that we have here, which is f of x, it is an exponential, because x is an exponent. Since x is an exponent, we are dealing with an exponential equation or an exponential function. Now, before we get through the questions, let us define the standard equation that defines the exponential equation or the exponential function, particularly for those learners who are doing technical mathematics. Then the standard equation of exponential equation, it says function of x, which is f of x, that is equal to a, which is parameter a, multiplied by parameter b, all to power of x, plus and minus q. This is the standard equation of an exponential function for those learners who are doing technical mathematics. Now let's start with parameter a. Parameter a, it tells us if this exponential curve, it will lie above the asymptote or it will lie below the asymptote. Now, how do we tell if it will lie above the asymptote or it will lie below the asymptote? If variable a, if the number before the base, we see that b is for the base that carry exponent x. If the number before the base that carry an x is a positive number, therefore the exponential curve, it will lie above the asymptote. Then if the number before the base that carry exponent x, it is a negative number, therefore the exponential curve, it will lie below the asymptote. That is parameter a. Now we come to parameter b. Parameter b is the base that carry exponent x. Now this one, it tells us about the shape. I'll repeat. The base, b is the base that carry our exponent of what? Of variable x. Now any number that carry an x, it tells us about what? The shape of our exponential curve. It tells us about the shape. Now, how do we now know which shape is the exponential curve going to take? If the value of b, it is greater than 1, meaning that if b, it is positive 2, if b is positive 3, If b is positive 4, now we are going to have an increasing exponential curve here. We are going to have our increasing exponential curve that start from asymptote going upwards. If the value of b it is greater than 1, meaning that if the base that carry exponent x, it is 2, it is 3, it is 4, it is 5, and so on and so forth, then we are going to draw our exponential curve that is an increasing. It's an increasing exponential curve. Now, if the value of b if b it is greater than 0, or if b it is less than 1, meaning that if b it is a fraction, in a nutshell, if the value of b it is given to be a fraction, then we are going to have an exponential curve that is decreasing. It is starting upwards and now it goes down towards the asymptote. Therefore, this one it is called a decreasing exponential curve. If the value of b it is a fraction, therefore we are going to have an exponential curve that is a decreasing, starting upwards, and it goes down towards the asymptote. If the value of b it is greater than 1, therefore we are going to have an exponential curve that is going upwards. That is that about the b. Now q, this q that it has a plus and minus sign. Now the q it is our horizontal asymptote. Any value that is here, it defines our horizontal asymptote. Remember, our exponential curve, it has only one asymptote. Then on the same breath, the q value, it shifts the graph up or down. If the value of p, or if the value of q it is a positive number, the graph is going to shift upwards. If the value of q it is a negative number, the graph is going to shift downwards. That is that about parameter A, parameter B, and parameter Q. Now let us indulge our questions as far as this question is concerned. We are given our function there. Then the first question for mark allocation of 1 mark there, it says write down the equation of the asymptote of f. Remember, now we come to this standard equation that defines our exponential curve. We have said the value here that it has a plus and minus here after the variable that carry an exponent x. The number that comes after that, it defines our horizontal asymptote. And this horizontal asymptote, it lies on the y-axis. Then since well here they are seeking us to find the equation, then equation it will be y. Why are we starting with the y? Because this horizontal asymptote, it lies on the y-axis, or we are going to get it on the y-axis. That's why we start with the with the y equals so. Now we see here we have this value here which represent the q, and we know that this value it is our horizontal asymptote. Then the equation it will be y is equal to -9. Mark allocation 1 mark in this regard. Easy peasy. 6.1.1. 6.1.2. It says determine the y-intercept. What is the y-intercept? The y-intercept, it is a point where this graph is going to meet with the y-axis. That point, it is called the y-intercept of this function, which is f of x. Then for us to get the y-intercept, in this case, which is the y-int, we call it the y-int, which is the y-intercept. We know by now that to find the y-intercept of any given function, we always let x to be equal to 0. How do we let the x to be equal to 0? Remember, what are we looking for? We are looking for the y-intercept of this function, which is what? F of x. Let us write that function. We know that f of x, it is the same as y, meaning that on the place of f of x, I can write the y because it is also the y. Then I'm going to say y is equal to, which is the f of x, in bracket 1 over 3, all to power of x, minus what? Minus 9. Now we are looking for the y-intercept. We are looking for the value of this part here, which is the y-intercept. For us to get this y-intercept, in a place of this x here, where we see variable x here, we are going to write 0. Why? Because x on the y-axis, it is equal to 0. That's why on the place of an x, we are going to write the 0. Then we have y, that is equal to, in bracket, 1 over 3, close bracket, all to power of 0 minus 9 there. And from the laws of exponents, we know that any base raised to 0, it is 1. Then here it means we are having a 1. Then 1 minus 9, we have negative 8. It means our y-intercept, it will be equal to negative 8. Mark allocation there, 2 marks. How do we locate that 2 marks? How do we allocate that 2 marks? Then we are going to give you 1 mark for writing 0 where you see the x. We are going to give you 1 mark where you have y is equal to negative 8. Then we are still proceeding. Let us erase here so that we have enough space. 2 marks there. Then 6.1.3. It says determine the x-intercept. Candidates, learners, remember there are 2 ways in this question. This question can be asked. The examiner can say determine the x-intercept. This is an x. This is the y-intercept. When you have y is equal to, it is called the y-intercept. But if the examiner has said determine the y-coordinate, now it means in this regard the examiner want this in a coordinate form. Now we know that the coordinate are divided into 2 parts. We have the x-coordinate and the y-coordinate. For us to get this x-intercept, the y-intercept here, what happened to the x? We made the x to be 0. It means the x-coordinate of this y is a 0. Then the y that we have this for this x-coordinate is negative 8. If the examiner wants it in coordinate form, you must write it in coordinate form. But if the examiner says the y-intercept, this is a y-intercept form. The coordinate form, the y-intercept form. I hope that is clear. Then 6.1.3, the examiner says determine the x-intercept. For us to have the x-intercept, or for us to get the x-int, which is the x-intercept, remember we let y to be equal to 0. Now, what x-intercept are we looking for? We are looking for the x-intercept of the function. In this case, the function, it is f of x. Now, we know that f of x is the same as the y. Meaning that where I see f of x, when I'm looking for the x or the y-intercept, in a place of an x, remember candidates, you can write the y. You only write the y when you are looking for the x-intercept or the y-intercept. Y is equal to, then what is our function? In bracket, 1 over 3, all to power of x minus 9. Then how do we get the x-intercept? Remember, we are saying in a place of an y, we are going to write the 0. Then 0 is equal to, in bracket, 1 over 3, all to power of x minus what? Minus 9. Now from here you need to isolate the constant number without variable x. Then you need to what? Transpose. Any constant number, when you are dealing with the exponential, you just have to isolate, transpose it to the left-hand side of the equation. Now this 9, it has a negative sign on the right-hand side. When you transpose this negative 9 to the side, it needs to change the sign. Since when it's a negative, when you transpose it to the left-hand side, now the sign changes to be a plus 9. That is said to be equal to, in bracket, 1 over 3, all to power of what? Of x. Now, those who are doing technical mathematics, they know that if you are dealing with the exponential equation, here we are having an exponential equation because the variable that you are looking for is an exponent. The exponential is from the word exponent, that's why we are having an exponential equation. Then how do we deal with the exponential equation where we are looking for variable x? Now we use the rule that is called logarithm. Logarithm, it allows us to make x the subject of the formula. Then we are able to move from exponential to logarithm. Then it says log, which is logarithm, log, logarithm. Log of what? The base. Remember, the base is the number that carry the variable that you are looking for. In this case, the number that carry the variable that you are looking for, it is called the base. In this case, it says log of the base. You write your base as the subscript there. Then we have the base 1 over 3. Then it says log of base. Then here you write your result. Your result is your constant number. Remember, the constant number is what? Is positive 9. That is said to be equal to your exponent. In this case, exponent is x. Now from here we move. Then you use your calculator to press log. Log of what? Base 1 over 3. Then our result, it will be 9. Then log of 1 over 3. Then that is going to give us an answer that is equivalent to x. To x is equal to -2. That is our x-intercept. Then how do we allocate the mark? 1 mark for x equals to 0, 1 mark for logarithm, and 1 mark for the x-intercepts, or the x-intercept, not the x-intercepts, but the x-intercept. That is that. We are still moving. We are still moving. Let us kindly erase so that we create some space for ourselves here. We know the y-intercept is -8, and the equation for the asymptote is -9. Then we go to 6.1.4. In 6.1.4, we are required to sketch, clearly indicating the intercept with the axis and the asymptote. Then let us sketch our function here. The x-intercept is -2. Then we are going to have -1, 2, and 3. 1, 2, and 3. Then 2, 4, 6, 8, 10. Two, 4, 6, 8, 10. 1, 2, 3. -1, -2, and -3. 2, 4, 6, 8, and 10. -2, -4, -6, -6, -8. What am I doing now? I'm not sure as to what am I doing. -8, -10. Now let's start with our asymptote. Our asymptote, it is at y is equal to -9. We go on the y-axis on the negative side. 9 is between -8 and -10. Then we are going to have our dotted line there. Then the x-intercept is at -2. The y-intercept, it is at -8. then let us see if we have the right thing there. -9, -8, then -2, not 2, -2, -2, not 2 here. It should be sorry, it should be -2, because the value of b, it is a fraction. We must have a decreasing exponential curve. That's what I wanted to check there. Then we draw our sorry, we must draw our decreasing exponential curve that passes through those 2 points. Then mark allocation there, 3 marks there. 1 mark for the asymptote, 1 mark for the shape, and 1 mark for those 2 x-intercepts. Then 6.1.5. Write down the range of f. What is the range? Give us all y values for which this graph it is defined or it exists on the y. Give us all the y's for which this graph it is defined or it exists on the y-axis. And we understand that this graph starts to exist from this asymptote as our reference point. Our asymptote it acts as our reference point. Then from the asymptote we see that we go upwards, and the graph is defined until it goes to the positive infinity. Then